Hello, precious students. I welcome you to our SHS2 Core Mathematics program, brought to you by the Center for National Distance Learning and Open Schooling. My name is Gershon. This is the third and final lesson on the topic Simultaneous Linear Equations. In our last lesson, we learned how to solve simultaneous linear equations in two variables by the substitution method. Now, we shall study how to use the elimination method to find the solution set of linear equations in two variables. So, our topic for today is solving simultaneous equations using the elimination method. The elimination method actually deals with removing one variable from the two equations so that only one equation in one variable is left to solve. We shall consider four simple steps. First, we make the coefficients of the variables in the two equations the same. Then, add the two equations if the signs are different. That is, if one is positive and the other negative, so that one unknown variable will cancel out. But if no variable cancels out, then thirdly, we have to subtract one equation from the other. Solve for the remaining variable and substitute to get the other variable. Let's take an example and go through the steps one after the other. Solve the simultaneous equations using the elimination method. X plus y is equal to 7 and 3x minus y is equal to 5. First, let's label the two equations as equation 1 and equation 2. That is, x plus y is equal to 7, equation 1, and 3x minus y is equal to 5, equation 2. Now we have to determine which variable to eliminate with addition or subtraction. Now take a look at the coefficient of y. This is so beautiful. It is the same in both equations, which is 1. That is cool. Also, the signs of the variable y are different. In equation 1, it is plus, and in equation 2, it is minus. And this is getting more interesting. Now, let's add the two equations vertically. That is equation 1 plus equation 2. And this will give us x plus 3x plus y plus negative y is equal to 7 plus 5. And this will give us 4x is equal to 12. Wow! What happens to y? Oh, y is gone. We have eliminated y. But that is good news because y plus negative y is equal to 0. So we have only one variable, which is x, to solve for. Now let's divide both sides of the equation by 4. So we have 4x divided by 4 is equal to 12 divided by 4. And that will give us x is equal to 3. Now to find the value of y, let's put x equal to 3 into either equation 1 or equation 2. From equation 1, which is x plus y is equal to 7, we obtain 3 plus y is equal to 7. And this will give us y is equal to 7 minus 3. And y is equal to 4. Therefore, the solution to our question is x is equal to 3 and y is equal to 4. I hope that was cool. Let's work another example. Find the solution set of the following simultaneous equations using the elimination method. 2x plus 3y is equal to 8 and 5x minus y is equal to 3. As usual, let us label the two equations as equation 1 and equation 2. So we have 2x plus 3y is equal to 8, and 5x minus y is equal to 3 as equation 2. Now, I want you to observe this carefully. Take a look at the two equations, and when we add them together, we will get 7x plus 2y is equal to 11. So nothing cancels out because we still have the x and the y in the equation. Also, when we subtract equation 1 from equation 2, the result is 3x minus 4y is equal to negative 5. And we still have x and y in the resulting equation. So it is not possible to add or subtract. What we can do here is to go back to our steps that we looked at in the introduction. We said the variable we want to eliminate should have the same coefficient in both equations. Oh, unfortunately, they are not the same in this case. So let's multiply equation 2 by 3 so that we can make the coefficient of y in both equations the same. And so multiplying by 3, we have 3 times 5x minus 3 times y is equal to 3 times 3. And that will give us 15x minus 3y is equal to 9. Because we transform or change equation 2 to equation 3, let's label this equation as equation 3. Then, what you can do is to put equation 1 and equation 3 together. Now look at it carefully. Now we have the same coefficient, but different signs. But this is good for us. What we have to do is to add equation 1 and equation 3 so that y will be eliminated. So we have equation 1, which is 2x plus 3y is equal to 8, and then 15x minus 3y is equal to 9, equation 3. So equation 1 plus equation 3 will give us 17x plus 0 is equal to 17. And solving, we have 17x is equal to 17. And now we divide both sides of the equation by 17. And so x is equal to 1. Now, in order to solve for y, we have to substitute or put x equal to 1 in any of the equations. But let's choose equation 1, which is 2x plus 3y is equal to 8. So whenever we see x, we put 1 there. So that will give us 2 times 1 plus 3y is equal to 8. And so 2 times 1 is equal to 2 plus 3y is equal to 8. Now let's group like terms. And so we have 3y is equal to 8 minus 2, which is 3y is equal to 6 because 8 minus 2 is equal to 6. Let's divide both sides of the equation again by 3. And that will give us 3y divided by 3 is equal to 6 divided by 3. And that gives us y is equal to 2. So the solution to our question is given by x and y, such that x is equal to 1 and y is equal to 2. Good. Let's take a look at another example with fractions. Solve the simultaneous equations 1 over x plus 1 over y is equal to 5. And 1 over y minus 1 over x is equal to 1. Again, let's label the two equations as equation 1 and equation 2. So we have 1 over x plus 1 over y is equal to 5, which is equation 1. Then 1 over y minus 1 over x is equal to 1. Let's name this equation 2. But take a look at the two equations carefully. X and Y are not properly aligned. So what we have to do is to rearrange the two equations so that the variables X and Y will be aligned or arranged vertically. So we have 1 over X plus 1 over Y is equal to 5. That is equation 1. And then negative 1 over X plus 1 over Y is equal to 1. And that is our equation 2. Now, looking at the two equations carefully, equation 1 plus equation 2 will give us 1 over X plus negative 1 over X plus 1 over Y plus 1 over Y again is equal to 5 plus 1. Remember, 1 over X minus 1 over X will give us 0. Therefore, we have 2 over Y is equal to 6. Now, we have to multiply both sides of the equation by Y, or we cross multiply. And this will give us 6Y is equal to 2. And now we have to solve for Y by dividing both sides of the equation by 6. And that gives us Y is equal to 2 over 6, which is equal to 1 over 3. To solve for the value of X, let us put Y is equal to 1 over 3 into equation 1. But remember that equation 1 is equal to 1 over X plus 1 over Y is equal to 5. And so, if Y is equal to 1 over 3, then we have 1 over X plus 1 divided by 1 over 3 is equal to 5. Remember, 1 divided by 1 over 3 is equal to 3. So we have 1 over X plus 3 is equal to 5. Now we have to group like terms. And doing that, we have 1 over X is equal to 5 minus 3, which is equal to 2. So we have 2X is equal to 1. And so we divide through by 2, giving us X is equal to 1 over 2. Therefore, the solution to our equation is X is equal to 1 over 2 and Y is equal to 1 over 3. I hope that was simple. So far, so good. Let's try another example on fraction. Solve the simultaneous equations 1 over 2x minus 1 over 3y is equal to 1. And 1 over 4x minus 1 over 9y is equal to 1. Let's label the equations as equation 1 and equation 2. So we have 1 over 2x minus 1 over 3y is equal to 1. So that is equation 1. Then 1 over 4x minus 1 over 9y is equal to 1. We label this equation 2. Now look at something here. If we add the two equations, we will get 3 over 4x minus 4 over 9y is equal to 2. And if we subtract, for example, equation 1 from equation 2, we will obtain negative 1 over 4x minus 4 over 9y is equal to 0. If we check this carefully, we still have x and y in the two equations. Neither x nor y cancels out. So the best thing we can do here is to clear the fractions in equations 1 and equation 2. How do we do that? We shall multiply equation 1 by the LCM, which is equal to 6. And so we have 6 times 1 over 2x minus 6 times 1 over 3y is equal to 6 times 1. Solving this, we have 3x minus 2y is equal to 6. Remember, because we have transformed this equation, let's label it as equation 3. We also have to multiply equation 2 by the LCM. Looking carefully, that LCM is equal to 36. If you multiply, we clear the fractions. So we have 36 times 1 over 4x minus 36 times 1 over 9y is equal to 36 times 1. And this will give us 9x minus 4y is equal to 36. Let's label this as equation 4. So from equations 3 and 4, that is 3x minus 2y is equal to 6, equation 3, and 9x minus 4y is equal to 36, which is equation 4. You can observe that when equation 3 is multiplied by 2, the coefficients of y will be the same. That is 2 times 3x minus 2 times 2y is equal to 2 times 6. And that will give us 6x minus 4y is equal to 12. Let's label this new equation as equation 5. So let's put 4 and 5 together. Equation 4 is 9x minus 4y is equal to 36. And equation 5 is 6x minus 4y is equal to 12. Now, what we can do over here is that since the coefficient of y is the same, negative 4 and negative 4, we have to subtract one of the equation from the other. So let's subtract equation 5 from equation 4. And that will give us 3x is equal to 24. Then, at this stage, what we have to do is to simply divide both sides of the equation by 3. And that will give us 3x over 3 is equal to 24 over 3. And that is equal to 8. So x is equal to 8. Now, to find the value of y, we have to substitute x equal to 8 into any of the two equations. However, in this case, we will substitute x equal to 8 into equation 3 to make our working very easy. Remember, equation 3 is 3x minus 2y is equal to 6. So we are going to replace x with 8. So we have 3 times 8 minus 2y is equal to 6. And 3 times 8 is equal to 24. Minus 2y is equal to 6. Now let's group like terms. We have 2y is equal to 24 minus 6. And 24 minus 6 is 18. So 2y is equal to 18. We now divide both sides of the equation by 2. And that gives us y is equal to 9. So our solution is x is equal to 8 and y is equal to 9. Wow, that example was quite long but interesting. I want us to try one more example, which is a word problem. The sum of the ages of Ben and Seth is 35 years. The sum of twice Ben's age and 3 times Seth's age is 89 years. Find their present ages. Let's use letters to represent the ages of Ben and Seth. So Ben's present age is equal to M, and Seth's age is N. Our equations will look like this. M plus N is equal to 35, equation 1, because we are told in the question the sum of the ages of Ben and Seth is 35. Then the second equation will look like this. 2M plus 3N equals to 89. That is the sum of twice Ben's age and 3 times Seth's age is 89. Looking at the two equations carefully, let's multiply equation 1 by 2 so that we can eliminate M. To do this, make the coefficient of one of the variables in the two equations the same. And that will give us 2m plus 2n is equal to 70. Also, let us subtract equation 3 from equation 2. And that will give us 2m minus 2m plus 3n minus 2n is equal to 89 minus 70. Solving, we get m is equal to 19. Now, to find the value of n, we have to substitute m is equal to 19 into equation 1, or any of the equations, but let's choose 1 for easy working. And so we have 19 plus n is equal to 35. And solving for n, we have 35 minus 19, and n is equal to 16. Therefore, Ben's present age is equal to 19, and then set age is 16. In other words, Ben's present age is 19 years, and set age is 16 years. That was lovely. Now, please try this on your own and refer to the notes for detailed solutions. A trader bought some bags of rice and some bags of beans for sale in his shop. Each bag of rice cost 225 Ghana cedis, while each bag of beans cost 240 Ghana cedis. If the trader bought 17 bags altogether and paid 3,960 Ghana cedis, how many bags of beans did he buy? As I said, try this on your own and refer to the note. Well. This brings us to the end of the third and final lesson on simultaneous linear equations. I hope you have learnt a lot. See you soon for another lesson. Till then, bye.